Good morning, everybody. Today we have a GCD equation, or sometimes people call it the highest common factor. But the parentheses here, and I'm just doing an example here to show you what this means in the event that you don't. Okay, so this reads the GCD or the HCF, highest common factor of these two numbers. By inspection here, it's equal to what? Let's make this 18. Sorry, let's make this 18. Okay, so that's an 18. So let's make this 6, right? 6 is the largest integer that divides both 18 and 30. So that's called the GCD, okay? Now, right here, we have a system of equations that involves this symbol, the GCD symbol, okay? So we're looking for natural number solutions. That means positive integers. And so it's rarely a bad idea to come up with what they call the prime factorization. 2028 without much trouble. It's discovered to be 2 squared times 3 times 13 squared. And so what happens here, we get a very favorable way of inspecting this expression or this system and actually getting the answer. Notice that 2 times 13 is the 26 you see right here. So you have 2 squared times 13 squared, and by properties of exponents, you get 26 squared right here. Now notice this just begs for a splitting sort of operation here. We're looking at mn equals to 26. So you see by inspection we can just write down, if we split this 26 with this 3, that'll give you 78. So we can write down 78 comma 26, okay? And that's very easy to see. The GCD of this is 26 itself, right? Since 3 times 26 is 78. And also, right here, the very same thing. This would be a solution to this equation right here, meaning you could write down 78 times 26. Excuse me. Right, 78 times 26 is equal to this just by stealing one factor of 26 and multiplying it by 3, right? And so we see that we can take m equal to 78 and n equal to 26 as our solutions. And again, inspection is totally valid here with the help of this GCD. I think it would be difficult to do this one in your head. Maybe some of you can. But anyway, there we go, folks. And either way, you could take m equals to 26 or n equals to 78. But these are two solutions. And something else to notice here is that if you take a look at this, this is in the form, we'll call it, what do you want to call it, b squared? Or we'll call this b right here. And then right down here you have b squared times some multiple, right? In this case it would be b squared. I'll just write times m. But you see, that's the connection here. If you have something in this form, it's always going to be a very easy to achieve system of equations. A constant, then the constant squared times some multiple. In this case, m was equal to this number here, 3. Now I'm mixing up the letters here. Sorry. Let's clear that up. Okay, we'll call it K, all right? Just to avoid any. We seem like we run out of letters in mathematics, right? But if you have this kind of structure, you're always going to have an answer. You're always going to have an answer. You just split it. It would be B and BK, right? So anyway, this is the solution to this particular problem. Hope you enjoyed.